Alright, welcome to our second video for today, guys. The first video talked about types or phases of matter. We had solids, liquids, and gases. Okay, now we're going to talk about properties of matter. Okay, we have two types of properties. We have physical properties and we have chemical properties. Physical properties, when we observe a physical property, the atoms or molecules in a substance do not change. Okay, so in order to observe a physical property, we're going to do so without changing the composition of my substance. Okay, so let's just say my shirt here. If I wanted to talk about a physical property, I can observe the color of my shirt, say it's blue, without changing the composition of the substance, without changing the composition of my shirt. A chemical property, in order to observe that, the atoms or molecules within the substance do change. Okay, so let's say that I wanted to figure out a chemical property of my shirt. Let's say the flammability, how easily it burns. Okay, in order to observe that chemical property, the composition of my shirt is going to change while I'm observing it. Okay, obviously, if I'm testing at what temperature or how likely it is to burn, that is going to change the composition of my shirt. All right, so chemical versus physical properties. The atoms do change or the atoms don't change. So I want you guys to tell me. I'm going to pop up a list here, and then I want you to tell me. You can pause the video and write down your guesses as to whether or not they are chemical or physical properties. All right, go ahead and pause the video. Okay, color. We talked about color. Obviously, it's a physical property. We can observe that prior to or without changing the composition of the substance. Flammability, we talked about that one as well. We can test that, but in order to do so, we have to change the composition of that substance, and so that makes it a chemical property. Boiling point is going to be a physical property, and we might think, oh, well, but if I go from a liquid water to a gas, are my particles changing? Well, if you think about it, we get H2O as a liquid, and we have H2O as a gas. It's still H2O. Okay, so we go just from a liquid water to a gaseous water. It's still the same substance. Those particles don't change, and so it's a physical property. Okay, solubility, that's going to be the ability for something to dissolve. And so like salt can dissolve in water. When salt does that, it stays as salt. It doesn't change. It stays as salt, and so it is a physical property, how easily something dissolves or does not dissolve. Malleability talks about solids and metals being able to bend without breaking. This pen obviously does not bend very well. It has a low malleability, but that's a process or a property that I can test without changing the composition of my substance. Okay, so that's a physical change. And then reactivity with oxygen. This word right here gives it away. Reactivity. And so I'm checking to see if this substance or whatever I'm looking at has any sort of reaction, chemical reaction with oxygen, and so that tells me that this property would be a chemical property. Okay, here's a couple more different types of properties. So we had chemical, physical. Now we're going to have intensive properties and extensive properties. Intensive, the characteristic, this property does not depend on the size. And so no matter how much or how little of something, this property is going to stay the same. Okay? Large and small substances, or large and small samples of the same substance, will have the same property. Extensive properties are the exact opposite. So this characteristic does depend on the size of the sample. So a large and small sample of the same substance will be different. Okay, let's look at some examples here. Same thing. I'm going to write or give you a couple of characteristics. I want you to tell me whether these are intensive or extensive. Pause the video, write it down. Color is intensive. It does not matter how much of my blue shirt I have. I can cut my sleeve off and have a little bit less, but it's still going to be blue, and so that gives it the intensive property. All right. Texture is also intensive. Cut my sleeve off of my shirt and it still feels the same as my actual shirt. I just have a little bit less of that substance, okay? Mass, now that is going to be extensive. The mass of a substance or a sample does depend on the size. And so if I were to cut my sleeve off and have just the sleeve and then I take my full shirt, those are going to have different masses. They're going to weigh different amounts. I have different amounts of them, and so that is an extensive property. Volume follows the same trend. Okay, obviously volume deals more with liquids, but they are very much size dependent. Okay, now density is a comparison or a ratio of mass to volume. We'll talk about density here after a little bit, but density is a ratio of mass to volume. D equals m over v. And these are both extensive properties. Extensive. And density is actually an intensive property. No matter if this changes, when mass changes, volume is going to change, and they're going to change at the same rate. Okay, and so because of that, density will always stay the same no matter how much or how little of the substance you have. For that substance, it's always going to be the same. So it is an intensive property. And flammability. So if we talk about paper, if I have a full sheet of paper or a small piece of paper, it's always going to have the same flammability. I might get a bigger flame because I have a larger fuel source or more fuel with a large piece of paper versus a scrap of paper, but the ability for it to catch fire and burn, that is going to stay the same. So it is an intensive property. And that is going to end video number 2.